Hello students, welcome to my YouTube channel. Um, Today is our last class in motion in 1D. Today we are going to solve some numericals. Okay, now let's start. Numericals. Numericals on motion in 1D. Example 1. The motion of a particle is described by the equation x equal to a plus b t square, where a equals to 15 centimeter, b equals to 3 centimeter. What will be its instantaneous velocity at time t-second? So we are going to find out instantaneous velocity at time t-second. The answer will be like this. We know that x equal to a plus bt square. Therefore, instantaneous velocity v equals to dx dt equals to 2bt, because a is a constant and we know that the derivative of a constant is 0. Therefore, this is a general equation of velocity dx dt. So velocity at t equals to 3 equals to, that is, this is instantaneous velocity, equals to 2 bt. And what is the value of b? 3. And the time value of time is 3 here. So it is 18 centimeter per second. So the answer is 18 centimeter per second. Next question, example 2. A person completes half of its journey with speed v1 and rest half with speed v2. Find the average speed of the person. Find the average speed of the person. So this is a very interesting question. Half of its journey with speed v1 and the rest half of its journey with speed v2. So we know two speeds, v1 and v2. Okay, so we have to imagine some things. For example, suppose this is the total path it describes, A to B. Half of its journey, if the length is d, the total journey is d, then half of it will be d by 2, and this is d by 2. This is O. This point is O. So average velocity, V average, is given by total displacement by total distance by total time taken. Now the total distance is d here, and the time is divided into two parts. The first part is given by distance by velocity, and that velocity is v1, and the second part is distance by second velocity is v2. So first time taken is d by 2 by v1, and the second time means the time taken to complete the rest of the journey, and the d by 2 by v1 is the time taken to complete the first part of the journey, that is the half part of the journey. Okay, so this is equals to d by 2v1 plus d by 2v2. So the LCM is d by 2v1 v2, and this is dv2 plus dv1. So it gives d into 2v1 v2 by d, taking common d, v1 plus v2. So the answer will be 2v1 v2 by v1 plus v2. So this is the answer, 2v1 v2 by v1 plus v2. Example 3. The displacement of a particle, the displacement of a particle is given by y equals to a plus bt plus c t square minus d t to the power 4. Find the initial velocity and acceleration find the initial velocity and acceleration. So we get, we have y equals to a plus bt plus c t square minus d t to the 4. Can you tell me what this equation indicates? Yes, right. Yes, this equation indicates displacement equation. So y is the displacement here. So we can easily derivative it with respect to time, and then we can get velocity. So v equals to dy dt. So dy dt will be a derivative of a is 0 because a is constant. dt b ct square, the derivative will be 2ct minus 4d tt. So this is the equation of velocity. Now what is the equation of acceleration? A equals to d2 dv dt. A equals to dv dt. So it will be 2c minus 12d t square. Okay. So this is the equation of acceleration, and this is the equation of velocity. But the question is, find the initial velocity and acceleration. So initial velocity means when time equals to 0. So v at t equals to 0 will be b plus 2c into 0 minus 4d into 0 cube, that is b. And acceleration at t equals to 0, that is initial acceleration will be 2c minus 12d into 0 square. So it will be, so initial velocity is b and initial acceleration is 2c. Here is an MCQ here. The question is, the retardation between time t and distance x is given by this equation where alpha and b are constants. The retardation is the options of these, okay? Where in the options we see that there is a term v, and v is velocity given in the question. So we have to find out the retardation. So t is given like this. So we write the equation at first. T equals to alpha x cube plus beta x. Now we find dt dx. Why dt dx? Actually we need to find out dx dt, but since it is given dt, equation of t is given, so we at first find dt dx, then we can reverse it. Okay. So dt dx equals to 3 alpha x square plus beta. Right? Sorry, the question was alpha x square. So it will be 2 alpha x plus beta. So we get v equals to dx dt, that is 1 by 2 alpha x plus beta. So acceleration equals to dv dt equals to dv dx dot dx dt. Why we just do this? Because v is dependent on x, but acceleration is dv dt, so we cannot directly differentiate v with respect to t. So we do this step, dv dx dot dx dt. And what is the value of dv dx? Minus 1 by 2 alpha x plus beta square into 2 alpha, and dx dt means v. So ultimately we get minus 2 alpha v by 2 alpha x plus beta. But 2 alpha x plus beta means v. 1 by 2 alpha x, that is minus 2 alpha this is whole square. So it will be minus 2 alpha v into v square. Why this? Because 1 by 2 alpha x plus beta equals to v, so it will be v square. So 2 alpha into v square, that is minus 2 alpha into v cube. So acceleration equals to negative sign, this means it is retardation. So retardation equals to alpha v cube. So option A is correct. Next question, example 5, and this is related with equations of motion. Example 5. A car moving with a speed kilometers per hour, 50 kilometers per hour, can be stopped by brakes after at least 6 meters. if the same car is moving at a speed of 100 kilometers per hour, what will be the minimum distance to stop it after application of brakes? This is the question. We know that v square equals to u square plus because it should be minus twice as, because retardation is applicable here. We are applying brakes, so retardation is occurring here. So the equation would be v square equals to u square minus twice as, implies 0 equals to u square minus twice as. Why is 0? Because the final velocity is 0 here, implies s equals to u square by 2a. Therefore s proportional to u square, since s proportional to u square, since retardation is constant here. Okay, so s1 by s2 equals to u1 square by u2 square. So what is the value of s1 here? S1, the value of s1 is 6 meter, s2 is unknown, u1 is 50, that is 50 square, and u2 square is 100 square. So it will be 6 by s2, 1 by 2 whole square, that is 1 by 4. So s2 will be 24 meter. Very easy. So the trick is here, is proportional to u square. You don't need to find out the acceleration. Many students do this. Actually they find acceleration, or better to say retardation at first, then they apply this retardation in the second case, and then they find the required distance. But this is a very long process. The shortcut method is just apply this concept, is proportional to u square, because acceleration is or retardation is constant here. Okay, we are applying same brake, that is why retardation is not changing here. Okay, very easy. Next, we are going to do some equations of motion under gravity. The equations of motion under gravity is almost the same. In this case, we just write G in case of A and H in case of H in case of S. So V equals to U plus AT, but we don't write A here, we write GT. Why plus G? When it is plus G and when it is minus G, it may be V equals to U minus GT. If G is if a body is falling downwards, then plus G. If a body is moving upwards, then it is minus G. Because when a body falls downwards, acceleration is positive, that is acceleration due to gravity. When it is moving upwards, its velocity ultimately becomes 0. That is, therefore there is some retardation, and that retardation is due to gravity, and it is denoted by minus G. S equal to ut plus half at square. It will be H equals to ut plus half gt square, or H equals to ut minus half gt square, depending on acceleration is positive or negative. V square equals to u square plus twice s, we write here v square equals to u square plus 2gh, or v square equals to u square minus 2gh. So these are the equations regarding motion under gravity. A very important question is here. This is example 6. A man drops a ball downside from the roof of a tower of height 400 meters. At the same time, another ball is thrown upside with a velocity (50 meters per second) from the surface of the surface of the tower. Find the height from the surface at which the balls meet. So to do so, we just draw a schematic diagram here. Suppose this is the tower. A ball is dropped. So dropped means E equals to 0 here. Okay. The total height is 400 meters. Suppose the balls meet at a distance h1 from the ground. So let's take the upper distance h2. The lower ball is thrown with velocity 50 meters per second. So in case of h2 we write ut plus half gt square. So u is 0 here, half gt square. In case of h1 we write 50t plus minus half gt square. Why minus half? I have said that when a ball is moving or any object is moving upwards, retardation occurs, so acceleration due to gravity is negative here. So minus half gt square. And what is t? Let t be the time at which the balls meet. Okay. Now h1 plus h2 equals to total height, that is 400 meters. So we write h1 plus h2 400. Implies what is the value of h1 plus h2? That is 50t. So 50t equals to 400 implies t equals to 8 seconds. So after 8 seconds the balls meet. So the required length, the distance that is from the surface h1 equals to 50t minus half gt square. We take g equals to 9. So it will be 50 into 8 minus half into 10 into 8 square. It will be 400 minus 5 into 64, that is 320 equals to 80 meters. So at a height 80 meters from the surface of the tower, the balls meet. This is a very good question, very important question. Another important question. Example 7. Another important question, a stone dropped from a building of height h and it reaches after t seconds on earth. From the same building, if 2 stones are thrown, one upwards and one downwards, with the same velocity, u, and they reach the earth's surface at after T1 and T2 seconds respectively. Then find the relation among T, T1 and T2. Very good question, very important question. Answer. Suppose the height is h, so h equals to half gt square. Very simple, because it is dropped and it takes t time to reach the ground, so it will be h equals to half gt square. For the second case, for the downward throwing, this is case 1, and in the second case, downward throwing, it was thrown, not dropped. Okay, so we write here h equals to minus u t1 plus half g t square, t1 square. Okay, why minus c? Because when we actually throw downwards, we take the velocity negative, because upward velocity is considered to be positive and downward velocity is considered to be negative. Why? Because you have written h equals to ut minus half gt square. Why u positive? Because you have taken the velocity u positive and acceleration is moving downwards. Acceleration downward is positive, velocity upward is positive. You have to keep it in mind. Velocity upward is positive, acceleration downward is positive. Velocity downward v or u positive, g positive. Velocity downward is negative and acceleration upward is negative. You have to keep these concepts. Okay, don't confuse these. Okay, so when the ball is thrown downwards, we write these. So this is equals to half gt square, because we have written it earlier, half gt square. So it is minus ut1 equals to half g t square minus t1 square. Very easy. And in case of third, upward throwing means upward is positive. So we write ut2 minus half g minus half gt square. Equals to t2 square, equals to half g t square, just written before, half g t square. So it is ut2 equals to half g or minus ut2 equals to half g the second case is moving upwards. So upward velocity is taken to be positive and acceleration is considered to be negative. So minus half g t2 square, half gt square. So minus u t2, or better to say u t2 equals to, it just changes t square minus t2 square plus t2 square. T square plus t2 square. So we take the ratio of these two. So t1 by t2 equals to t square minus t1 square by t square plus t2 square. Okay, so it becomes t1 t square plus t1 t2 square equals to t2 t square minus t1 square t2. So after changing the side, we get t square, taking common t square, t1 minus t2, and it becomes, if we take T1 T2, this is minus T1 T2 minus T1 T2 T1 plus T2. The question was one upwards and other downwards, thrown downwards, thrown upwards. So upward means positive. T1 plus T2. So it will be T square equals to in case this is the first case, this is the thrown downwards, and when it is thrown upwards, wait, when it is throwing downwards, just forget this concept. When we are throwing downwards, downward velocity is considered to be positive, ut1 plus ut1, and when it is throwing upwards, this is minus and this is plus. Okay, this is minus and this is plus, because we always take downward direction positive and upward direction negative. So upward velocity is negative, and ultimately it is moving downwards, so g is positive here. Okay, so it becomes ut2 minus ut2 equals to minus ut2 minus ut2 equals to this minus ut2 half g t square minus t2 square. So ultimately it becomes, the ratio becomes t1 minus t2, t1 by minus t2 equals to t square minus t1 square, t square minus t2 square. So t1 t square minus t1 t2 square plus t minus t2 t square plus t1 square t2. Okay, so after changing the side we get this plus, and this is also plus, t1 t2 taking common. So t square becomes t1 t2 t1 plus t2 by t1 plus t2. So t square equals to t1 t2. So t equals to root over t1 t2. Very good question, t1 t2, and very confusing one. So practice several times. If you don't practice several times, you cannot solve this. The concept is downward velocity is always positive and upward velocity is negative. So in this case the velocity is downward, so it is positive. In this case the velocity is upward, so this is case 1 and this is case 2, and this is downward motion, and this is for upward motion. Okay, so practice all these sums, and I have done all the types of sums, almost all the types of sum. You have to practice these and these again and again. So if you like this video, please subscribe my channel and wait for the next video. If you subscribe my channel, then you can get the updates quickly. If you like this video, then press the like button. Thank you.